Hey, welcome back. So last time we divided monomials by monomials, but this time in section 5.11 we'll have polynomials divided by monomials. So first off, we'll start off with what we've seen before. So if we're given something like 23 divided by 4, we can break this apart and write it like 20 plus 3 divided by 4. Now remember, with fractions, the denominator down here has to be the same. So then we can rewrite this as 20 divided by 4 plus 3 divided by 4. See how we have our the exact same thing in the denominator? That's the only way we can add these. Now it's the same if we just have a variable added. So if we have 3a plus 3b divided by 3. This just equals 3a divided by 3 plus 3b divided by 3. Now, does this look a little familiar from what we saw last time? When it's written like this, we can rewrite it as 3 over 3 times a over 1 plus 3 over 3 times b over 1. And we end up with the 3 divided by 3 is 1. So we get 1a plus 1b. And so it's just a plus b. Alright. So what if we're given a situation like this with exponents? 2rs minus 6r squared s squared divided by 2r. Well, you can rewrite this still as 2rs divided by 2r minus 6r squared s squared divided by 2r. But then we split this up, so it's 2 times r times s divided by 2 times r minus 6 times r times s divided by 2 times r. Remember last time how if we had a 2 and a 2, 2 divided by 2 is just 1, so they cancel. So it looks like this. We have r divided by r, they cancel, so that just leaves us with an s up here. And then we have a negative 6 and a 2, so negative 6 divided by 2 is a negative 3. We have 1r here and 1r here. R divided by r is 1, so they cancel. And then we have no other r's or s's down here to cancel these up here. So then that just leaves us with r s squared. And that's our final answer. And what if we have something like 2x squared plus 4x plus 8xy divided by 2x. Now instead of writing it out like before, like we did here, we can simply write it like this. 2 divided by 2 times x. Now, what do we remember about exponents when we're dividing? 2, and this is a 1 here, right? So we end up with 2 over 2 times x to the 2 minus 1 plus 4 over 2 times x to the 1 minus 1 plus 8 over 2 times x to the 1 minus 1 times y. Now this is technically a times y to the 0 power, because anything 3 to the 0 equals 1, a to the 0 equals 1, 5 to the 0 equals 1. Anything to the 0 power is 1. So that's why we can write this as y to the 0, because anything times 1 doesn't change anything. So if this is a 0, and this is a 1, we can write this as 1 minus 0. And then we end up with 2 divided by 2 is 1 times x plus 4 divided by 2 is 2 times x to the 0 plus 8 divided by 2 is 4 times x to the 0 times y. This just simply gives us x plus 2 plus 4y. And there's our final answer. Now, just as a reminder, we don't want to confuse these two things. If I have 5x squared plus y divided by 5x squared, how is that different from 5x squared times y divided by 5x squared? Well, up here, I rewrite this as 5x squared divided by 5x squared plus y divided by 5x squared. And because when we add, we have to have the same thing in the denominator in order to add things. But this is not the case in multiplication. In multiplication, this equals 5x squared times y divided by 1. Now notice the differences here. We have a plus sign here, and so we have a plus sign here. I have a multiplication sign here, so I have a multiplication sign here. With addition, we have to have the same thing in the denominator in order to add. But with multiplication, we don't. So make sure that you don't confuse these two. When it says to add, this is what you can write. When it says they're multiplied, we have to rewrite it like this. So that's just a quick reminder to you so you don't confuse those two, because we've been working with both of them.